As part of their work with avalanches, many avalanche practitioners ski cut specific slopes. That is, they try to trigger avalanches on those slopes. Subjective opinions about the risk of ski cutting vary so widely that discussions about ski cutting often fail. So, we recognize the need to quantify the risk. In the spring of 2019, we conducted an online survey as a first attempt to quantify the risk from ski cutting. The main goal of the survey was to provide a quantitative estimate of the risk in order to inform discussions, decisions, and practices about ski cutting. This video summarizes some of the key results of the survey. At the end of this video, I'll explain how to find an online paper that contains more information on ski cutting and the survey results. For this study, I teamed up with Karl Birkeland, Mark Vesely, Ilya and John Stimberis. Here is a video of a practitioner ski cutting and triggering dry slab avalanches. Note that the practitioner was able to stay at the top of the slope to reduce the risk. In this clip, watch as the practitioner starts at the top of the slope, but, to keep moving, finishes the cut well below the top of the slope. In the specific snow conditions, the risk is small because the practitioner is triggering loose, wet avalanches which reliably start at, not above, the practitioner's skis. Here is a very brief background on ski cutting, just a few highlights from the online paper. As a way to remove unstable snow, ski cutting has been mentioned in publications going back to 1936. According to some of the older avalanche course manuals on our bookshelves, ski cutting was being taught, at least in Canada, to avalanche practitioners in 1974 and to winter recreationists in 1985. Some publications distinguish between two types of ski cutting, either testing for unstable snow or for removing unstable snow, that is, mitigation. Ski cutting remains widely used. The Canadian Avalanche Association's 2015 competency profile includes artificial triggering without explosives, which clearly includes ski cutting. The disadvantages of ski cutting involve risk to the practitioner. Doug Richmond and Mark Vesely have identified patterns in near misses and ski cuts resulting in injuries. The online paper describes other risky situations. Of course, this video and the online paper provide quantitative estimates of the risk of ski cutting. The advantages of ski cutting include it provides evidence of unstable snow, often before natural avalanches occur, which is key information for avalanche forecasting. Ski cutting can remove unstable snow before others with lower skills enter or travel below the slopes. Ski cutting is more effective for triggering loose, wet avalanches than explosives. In some avalanche operations, ski cutting is efficient and cost-effective. Also, practitioners can learn about snowpack variations over terrain that are relevant to avalanche release, about placing explosives and route selection, as well as how instability comes and goes, all of which are important to avalanche work and difficult to teach in the classroom. In this photo, my partner and I were ski cutting shallow slabs at the Fernie ski area. On this particular slope, a deeper weak layer released, as you can see by the stepped crown fracture. These are my skid marks as I tried to arrest while the avalanche carried me down the slope. Clearly, there is uncertainty in the size of avalanches triggered during ski cutting. In Canada, there is one record of a fatality during ski cutting. This occurred at a ski area in 1994. The rescue was delayed because the ski cutter was not using a transceiver and was carried out of sight of the observer. Karl Birkeland searched through the records for the United States and found 3 avalanche practitioners killed by avalanches during ski cutting. In the same time interval, there were 9 avalanche fatalities and 7 incidents with mitigation by explosives, specifically hand charging. Of course, the risk of ski cutting cannot be compared with the risk of hand charging, since explosives are preferred for larger slopes and deeper slabs. However, these fatalities indicate that while hand charging is sometimes a good alternative to ski cutting, it is not without risk. Okay, let's look at the survey results. We received complete responses from 161 practitioners in the United States, Canada, and New Zealand. The survey allowed respondents to report their ski cutting results for 1 or 2 phases or sectors of avalanche work. For example, a practitioner's first avalanche career phase might have been at a ski area, and their second career phase might have been ski guiding. 50 respondents provided complete responses for a second career phase, giving us data for 211 career phases. However, to analyze the risk for specific sectors, we only received enough responses for 2 sectors, 128 for ski areas and 45 for mechanized ski guiding. The respondents reported a total of almost 1.5 million ski cuts. But how much ski cutting do practitioners do in an average winter? This table shows the number of career phases, which you can think of as the number of respondents in a particular sector. This is the total number of ski cuts reported in the sector. Since we know the number of winters in each respondent's career phase, we can calculate the average number of ski cuts per winter per practitioner by sector. And since the averages are influenced by extreme values, here are the medians for ski area practitioners and mechanized ski guides. The medians are round numbers because the respondents estimated the number of ski cuts per winter. However, the wording in the survey discouraged practitioners who did limited ski cutting, so these numbers better represent practitioners who are quite active in ski cutting. I'll refer back to this table in a few slides. This graph shows the rate of triggering by avalanche size. Because some of the rates are quite small, most results, including those in this graph, are scaled to 1 million ski cuts. On the scale of 1 million ski cuts, about 2 to 400,000 size D1 to 1.5 avalanches are triggered. So the triggering probability for these small avalanches is about 0.2 to 0.4 depending on the sector. That is a high probability because the objective for mitigation by ski cutting is to remove unstable snow by triggering small avalanches. Note that size D1 avalanches are, by definition, relatively harmless. The rates of triggering larger avalanches are much smaller, so that they're hard to see on this graph. To get a better look at the rates, let's switch the left axis to a log scale. Now we can see the columns for the larger avalanches. For size D2 to 2.5 avalanches, about 4,000 are triggered per million ski cuts. So about 100 D1 avalanches are triggered for every D2 avalanche. For D3 and larger avalanches, about 140 are triggered for every million ski cuts. So about 30 D2 avalanches are triggered for every D3 and larger avalanche. We'll get to the differences between sectors in a few slides. This graph shows the rate of being caught in 1 million avalanches triggered during ski cutting. The left axis is a linear scale. Clearly, once an avalanche is triggered during ski cutting, the probability of being caught goes up with the size of the avalanche. The graph indicates that being caught in a triggered D3 plus avalanche is about 10 times more likely than being caught in a triggered D1 1.5 avalanche. Okay, it's time to talk about the risk of injuries. Here are the risk triangles for ski area practitioners and for guides in mechanized skiing. Starting at the bottom, there are about 3 to 400 near misses per million ski cuts. For injuries that result in light duty, there are about 18 and 37 such injuries per million ski cuts. For injuries that result in missed work, there are about 3 and 12 such injuries per million ski cuts. For injuries that end a career phase, there are about 1 and 9 such injuries per million ski cuts. The survey was based on the personal recollection of the respondents, so of course we have no data for deaths. However, the online paper does estimate this rate. The triangles are scaled by the number of injuries in the sector. So for the same number of ski cuts, the survey suggests that mechanized ski guides have about 2.5 times more injuries than ski area practitioners. Why might the ski cutting risk be lower for ski area practitioners than for mechanized ski guides? Here are 3 possible explanations. 1, the difference may be due to ski area practitioners having better options for explosive use when the risk on a particular slope is higher. 2, the slopes that ski area practitioners ski cut are more often ski compacted than slopes in the backcountry, reducing the frequency of deeper than expected slab avalanches. Or 3, ski area practitioners may have a long list of slopes to ski cut when there's only a few centimeters of new snow overnight, that is, when the risk is very low. The average risk to avalanche practitioners shown in these 2 graphs may be acceptable in view of the benefits of ski cutting, which includes reduced risk to the people in the care of the avalanche practitioners. Of course, the risk to avalanche practitioners varies by operation. Also, improvements to operational safety plans may reduce the risk to avalanche practitioners below the average levels estimated by this 2019 survey. So you're probably wondering, what is a practitioner's risk per winter? For this, we use the median number of ski cuts per winter per practitioner from the table shown early in this video. Now, because the injuries per winter is a small number, we flip that ratio upside down to give the average number of winters per near miss or injury. The left axis of this graph is a log scale to better show the results that are small numbers. The survey suggests that a practitioner would, on average, experience a near miss about every 6 to 10 winters. A practitioner would, on average, experience an injury resulting in light duty about every 90 to 140 winters. The survey suggests that injuries resulting in missed work or ending one's career phase happen even less often. Because the average number of winters for more serious injuries for an individual practitioner are around 1,000 and rather hard to comprehend, let's try a different approach. Instead of winters per injury per practitioner, let's look at winters per injury per operation. The winters per injury within an operation can be roughly estimated by dividing the numbers in the previous graph by the typical number of practitioners in an operation who are actively engaged with ski cutting. Consider an operation with 50 practitioners who actively ski cut slopes. The number of winters per light duty injury would be about 140 over 50. So on average, there would be a light duty injury about every third winter for a ski area, and 90 over 50. So on average, there would be a light duty injury about every second year for a mechanized ski guiding operation. Avalanche operations can adjust the number of ski cuts per practitioner and the number of practitioners in their operation to check if their rates of near misses and injuries are roughly comparable to those in the study. However, the duration of near miss and injury records should preferably be at least 3 times as long as the number of winters for the type of injury. We hope the quantitative estimates of risk in this study will promote informed discussions, decisions, and operational practices for ski cutting. Here is the QR code to get to the online paper, which includes more background on ski cutting and on the survey results. Or you can search the web for Ski Cutting Risk Survey Results. We are grateful to the respondents who completed the rather difficult survey. Thanks also to my co-authors and to those that encouraged the study and commented on the draft survey. Their comments improved the survey and its results. Also, we are grateful to the associations that distributed the survey to avalanche practitioners. And thank you for watching this video and for putting up with all the graphs.